changed, and we'll leave the portions that should not be changed. And that is the power of HTMX, okay? And the power of HTTP, Hypertext Transfer Protocol, where we can create very small sections. Now imagine that you could create only just very small portions of your application, and then depending on where and what was clicked, just those small portions could be changing. That's the idea behind HTMX, okay? Now, this is not a tutorial or a lesson where we talk about HTMX. HTMX is just a means to an end. It's just a means to an end, but it is extremely, absolutely, completely, totally important that you understand the concept and the idea behind HTTP. Because if anything that Bitcoin and whatnot has taught us is that having a decentralized, having it's like all of these things, okay? The technology changes very, 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 very fast, and it is extremely important to be able to respond fast to any changes than to be smug and comfortable with the things of yesteryear. Okay? Let's go ahead and do a couple of more exercises. And then, I think it's straightforward enough. The only thing that I did here was I put the address. I went to the back end. And then tied so having said that, I created a small card, okay? Created a small card. I added HTMX to the page. I added a single tag to the element. I came and created the back end for it. And then, at the end of it, when I clicked, just that portion changed. So, the reason why I'm saying all this is for you to understand the journey that has happened over the past couple of hours, past couple of days, okay? The journey that has happened over the past couple of hours and past couple of days. We have touched, in just this small time, what it took for HTMX to work. I touched JavaScript, I touched HTML, I touched Python, I touched many different things for just this to happen. And I'm hoping that is showing you that there is a need for that polyglot, well-rehearsed, well-rounded, highly motivated engineer. Because at the end of the day, what is going to happen is this. You focus too much on JavaScript and you leave Python. You focus so much on Python, you leave JavaScript. You don't focus on any of them. And as a result, your skills and your potential for growth suffers. To be able to build anything of repute, you need to have a wide breadth. You need to have a wide breadth. You need to be able to touch multiple things and make do with the multiple things that you're touching. You need to be able to touch multiple things and make sense of the multiple things that you are touching. Okay, so we were able to take a look at how, even for something as small as HTMX, a lot of work is required across the different tools that we have been learning over the past couple of days. I hope you see the importance of what I'm trying to say. So we touched JavaScript, we touched HTML, we touched Python, just to make this small. When I click on a page, only that part should load. Again, very, very powerful. Look at it, okay? I click here, only that part changes. The page does not change, okay? For instance, I named here goat meat. I click here. You see that this place is still called goat meat. It didn't change. It is still exactly the way it was, okay? So it is a very, very powerful technology in that it allows you to be able to get the same thing you would normally get from an Angular or a React or a whatever without having to go through all that headache and all that migraine that comes with client out routing and all the nonsense, and like you don't have to suffer all of that, okay? But to be able to fully implement this, of course you can do it solely in JavaScript. I had to touch Python, I had to touch JavaScript, I had to touch HTML, okay? So the more rounded you are as an engineer, what I'm trying to say, and this is the point I've been trying to make for a very long time. The more rounded you are as an engineer, the better off you are. The more capable you become. The more you are able to do things that someone else might do and stop somewhere, okay? This is not a call to bragging. This is not a call to... The more rounded you are as an engineer, the more capable you become. The more sought after you become. The more in value you become. Okay, so now that we have taken a look at how easy it is to get some parts of your page to change and some parts of your page to stay the same, it is actually quite easy to build something like that, at least from the user interface perspective. The same way you have like Airbnb and things are changing, but the whole page is not changing. To be something like Netflix is kind of very complicated, but you get a picture. You can build progressive, more recent web applications without having to go and hire an entire design team just to tell you what colors are great and what colors are not, okay? So, moving on. If you want to be able to continue working with HTMX, if you want to be able to continue, then my first port of call would be you take careful analysis and stock for what is it you want to achieve in the next 10, 20 years, okay? You take stock of what is it you want to be able to accomplish from a programming perspective, and you start taking small baby steps to get there. If it is AI, you start taking small baby steps to get there. If it is cybersecurity, you start taking small baby steps to get there. But you need to have that holistic overview, okay? You can start small, build until you get competence, and then move from there to a greater height, okay? So if you want to start working with HTMX, get a holistic overview, what exactly you want to go, what are the things you want to accomplish, what are the things you want to achieve. Bite down. If you say somewhere along the line you want to make the transition and start using React, Vue, Svelte, JS, or whatever new fad technology is out at that point in time, you would know that it was in line with your expectations when you started the journey, okay? You know it is in line with your expectations when you started the journey. Okay, so we've taken a quick look at HTMX. Another thing that I think greatly benefited was you saw how easy it is to implement something like this once you know what is it exactly you're doing. Once you know what is it exactly you're doing. Okay? You can actually even click here and have here change. Okay? You can click here and have here change, or have here change, and have anywhere change. Okay, so moving on from this, the document object model is the API via which you interact and you play with the document that the browser sends. There are numerous events that happen within the confine of the browser. There's the mouse, there are mouse events, there are keyboard events, there are so many different events. Another assignment, when you have the chance, okay, just read up on event system. Read up on event system in the DOM, and I think it will be a wonderful conversation to have after you've read up on so I see a question in the is it the same listening events? Every event that happens in your browser inherits from the same system event. There's no difference, okay? All the events all come from one source. The way events work, all of them it's just one big family, okay? Your browser, everything that is going, the minute you open your browser, everything you're doing is tracked as an event. You're scrolling your mouse is tracked as an event. You're pressing the button down is tracked as an event. Now, what you can do is you can tell the browser, I want to subscribe to this event. When it happens, tell me. But if you think about it, the only way and the only reason you say you want to subscribe to an event is because the event has been happening all the time. Like it's been happening even before you say you wanted to subscribe to it. So your browser is in the business of events. Your browser is in the business of events. Your browser, the minute you open the browser, its constant job is, okay, has he pressed the keyboard? Has he moved the mouse? Has he done this? It's just events, 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 events. Those events are firing. You just are not being notified about it. Okay? They're firing. You're not just being notified about it. Because if you think about it, how will the browser know to tell you when an event has happened if it's not tracking the event all the time? So it's always tracking the event. You just choose to say, tell me when it happens so I can run my own code. But the browser is always listening to the events. It is not when you start listening to an event that the browser starts. No, it is there all the time. Okay? If you're not listening to it, other people and even the website that you might be on might be listening to that event, even though you're not. Okay, so let's move on. Now, taking a look at this and seeing how easy it is to swap only parts of a page, like swap only small parts of the page, and change the small parts of the page with the content that you want. What then is the seeing how easy it is to swap the different parts of the page, what then would you say is a great barrier that many websites are not doing things like this and whatnot? Now we're going to talk about the employability of the skills that you want to get as an engineer, and why is it that specific skills are not in demand even though they might be simple or easy, okay? The fact of the matter is that there is nothing you will write or code as an engineer, okay, that will make somebody sit down and say, wow. Like, it's very, very difficult. Even in the place that you work, you will have engineers that you work with, and like, oh, yeah, that's neat. But nobody's going to sit down and say, wow, because even me, when I take a look at code that I wrote years ago, I don't sit down and say, wow, okay? So the most important thing is not for you to get bogged down with, oh, this technology is simple, this technology is great, this technology is this. The most important thing for you to do, again, I'm going to repeat myself, is say to yourself, in XYZ amount of time, I want to be this kind of engineer, and start working towards it, okay? The only thing I can do is tell you, this is a cool technology, this is how easy it is to get started, this is what it does, this is what Python does, this is what JavaScript does, these are the tools that you have, and then you decide what you want to do with that knowledge. Okay, so I think it's maybe because I am tired, I'm not saying it exactly the way it should be said. This is what I'm saying, okay? I will dump a lot of information on you about engineering, about technology, about Python, about JavaScript, but you need to choose what kind of engineer you want to be, not listen to what kind of engineer that I am, as I'm teaching you some of the things that I know, okay, and as we're going on this journey together. That is the only way you will make the most out of this interaction that we're having. Having said that, let's move again to another component or another part of the system that we're going to be building. Like, if you take a look here, you see this is part of the system that we're supposed to be building, okay? This is a part of that system that we're supposed to be building, and this is also a part of that system that we're supposed to be building, okay? And there are numerous other portions and components that are supposed to be part of that system. Let's take a look here and see. I think I remember it was skills. Okay. And earlier you saw we were creating the an ability for you to create skills and whatnot. So there are numerous things, numerous technologies, numerous things that can be built, numerous. At the end of the day, they really don't matter. What matters is what you want to do and where you want to go. Okay? What you want to do and where you want to go. So before we move to the next section, I want you to have that at the back of your mind. As we're programming and explaining, I want you to have that at the back of your mind. Okay? That is going to help you with the questions you ask. That is going to help you with the way you understand and or grok material. Okay? So let us take a look, not at some of these templates. I honestly think if I take a look at some of these templates, I might sleep, because just even taking a look at the HTML is putting me in a sleep phase. So let's go back to something that has not put me in a sleep phase, so that I can, because there's just a lot to explain. For JavaScript, I have to talk, then code a little, talk, then code a little. For Python, we can code and learn together, okay? So let's take a look at the API that we talked about, and let's take a look at hypermedia as the engine of application state, which is something that we are supposed to start. Hypermedia as the engine of application state basically is saying that your API should be self-descriptive, okay? Let's leave this guy alone. Medium, no way. Your API should be self-descriptive. So if you go to a bank and you visit account/12345, you should get the account number, the balance, and you should get links. Deposits, if I want to deposit, I go to this link. If I want to withdraw for withdrawals, I go to this link. If I want to transfer for transfers, I go to this link. For close requests, I go to this link, okay? Your API should be self-descriptive. And what we're saying, and the aim of this Code-A-Thon is not just that your API should be self-descriptive. Your API should be fully representative of your system. So in other words, if you are trying to build a system or a software component or whatever, every single thing that that software component can do should be available via your API. That is, some people say you eat your own dog food. Anything, any software, any functionality, any logic, any feature that can be carried out by that system should be available via an API. Let me tell you why, okay? Can you imagine you bought a TV, and the TV you bought doesn't have a way to take the volume down, okay? The only way for you to take the volume down is for you to walk to the TV and then press a button on the TV for the volume to go down. You would cost the makers of the TV on end, okay? If the remote is the API to the TV and they try to make it as complete as possible and don't leave anything on the TV, you shouldn't leave anything in your application that cannot be done via an API. Just like, you shouldn't be doing that, okay? You need to build a fully representative API, and the API needs to be very RESTful, have hypermedia as the engine of application state, be self-descriptive, and the API itself will make you money, okay? Moving on, let's take a look at this, okay? And let's see how we can take that and implement it with this API that we've been doing here, okay? If we say we want to add hypermedia as the engine of application state to the APIs that we've been building so far, okay? Then, in addition to returning data, okay? In addition to returning data, we are going to return metadata, okay? In addition to returning data, we are going to return metadata. What does that mean? So I know that this endpoint is the endpoint for creating an individual, okay? I should have a graph or like a map of all the related actions that are associated with creating an individual, okay? So for instance, API design thinking, I would say, okay, when I create the user, instead of just returning none, okay, I can return the user data. At the same time, I'm going to return a link that says edit, and then it gives you where you go to edit the user. I'll give you a link that says skills, okay, attach skills. It will give you a link that if you click on will enable you to attach skills and whatnot. So my API should be self-descriptive such that even if someone came from to integrate with a mobile phone or a desktop app or another web app, like it should be easy, okay? Now, the question I'm going to ask is, let's imagine we want to do that on this API. Right now, we have this function here to create an individual. How will you make it such that this function, okay, returns the right links to the person that called the function? The answer is actually quite interesting and quite exciting. And the reason why I'm asking is because I want you to think from the context of an engineer, okay? I'm talking to you to AKP. Imagine that you have an endpoint, and when the endpoint returns data, you want it to be so aware that it knows the other data points or the other APIs that it should give back to the user. And then it gives those APIs back to the user. Not all at once. Not all at once. Okay, let's do this. So there are numerous ways to go about it. There are numerous ways for you to say, hey, when you call my API, I want to give you the list of other APIs that you can call, and this list of APIs should enable you to do X, Y, Z or do ABC, okay? One way you can go about it is to say you want to group your APIs by models, okay? You want to group your APIs via models. Another way you can go about it is you can say, when people are doing something on my API, I want to be collecting all the APIs that they're visiting in tandem with mine. Like when somebody logs into my bank account and he deposits money, then he goes to do something else. What is, what are the things that he does? Like that is the most tricky and the most difficult, okay? Another thing you can do is you can ask yourself, from a design thinking perspective, what is it that someone is like, what is the user flow for my application, okay? Somebody logs into my app, the first thing he does after logging into my app is check his account balance, okay? The minute you log in, then I should be giving you the account balance and whatnot. Or if the user flow is that you buy something, and then when you buy something, you put it in your shopping cart. When you put in your shopping cart, like you want to check for similar items and whatnot, and then you can give them such links. when that action is performed. That's at the contextual or the conceptual level, okay? I hope you are excited enough to be thinking about that and be thinking about how you're going to implement it in code, even if you can't write the code. That's the first step to being a great engineer. Now, the second step is you have found out that this is something that you want to, like this is the user flow. How would you actually implement it? When I take a look at the code on the screen, the first thing that comes to mind is, one, I can use some sort of aspect. That's, I'm going to come here and say something like at length, and then I'm going to give it some sort of text, and then based on that, as the data is being sent out, it is going to make sure that those links are sent with the data, okay? So it will take a look like, okay, this is what I'm taking a look at. This thing that I'm taking a look at has a relationship with 1, 2, 3, 4, 5, and that is what I am going to send out, okay, to my customers. That is one way that I would take a look of going at it. Another way that I can take a look of going at it is to say, how has other people that have implemented something like this done it in the past? How have other people that have implemented something like this done it in the past? So as an engineer, you want to make sure that you are learning from your peers. But this is not a lecture on learning from peers. This is a lecture on coding. So unless someone has an alternative that they think is better than the links with the skills that we put here, I am going to go ahead and code that in a couple of seconds. Anyone? Okay, so let's go ahead and do this, okay? Now, I was hoping that somebody would indulge and we could discuss about this a little bit, okay? But since nobody indulged, I'm going to give you my personal indulgence in this. Now, I am hoping that over the course of the next, I can stimulate the engineering thinking in you. The minute somebody says, I'm thinking of doing this, the engineer in you should ask, is there something better that I can do? Okay? I am thinking of creating this decorator that would take a string. How sustainable is it? Is there something better? Is there something better than I can do? Is it possible for me to use a more efficient way to send feedback or send data? To send that data? Okay, let's take a look. If we say we want to do this, okay, let's critique this together. It means for every single endpoint, we're going to have to do this link skills, link skills, link skills, which is going to become tedious, okay? Problem number one. Problem number two, you're going to have to be maintaining whatever internal data store you're using for the skills, okay? So it has to be something that is a lot more efficient, something that doesn't have to do with placing decorators directly on functions. So one of the ways that we can solve that problem is by saying whenever somebody whenever somebody okay, whenever somebody visits our site, okay, or whenever somebody visits, there are a couple of things that happen before it even gets to your function, okay? There are a couple of things that happen before it gets to your function. It is possible for you to say, before every single request that comes to my, it's like when you hear people say you must pay machine ground, or boy, you don't pay machine ground. It's like a slang in Nigeria, for those of us that are not Nigerian, where you have to pay money to enter into an environment, okay? You have to pay money to enter into an environment. That's basically what it means. So we can do the same thing and say you don't pay machine ground, okay? For heaven, for the web browser, for the web application you're building. How are you going to do that? You're going to come here and you're going to say app, okay? App dot before every application. I'm going to give it a string that will do something for me, okay? The same way I can say app dot after every application, okay? Now, what is happening here, or is that whenever I say app.before, okay, it means that before every single application that comes, okay, if it's a post, if it's a get, if it's a delete, if it's like, it doesn't matter. Before every single application request that comes, you have to give the piper what belongs to the piper, okay? That's something that can be done. Another thing that can be done is after every single request that has been handled, I want you to run something, do something for us, okay? So these are two ways that you can go about adding some contextual data to your application. So here you can actually now come and say that I have a database of applications that I want to, like I have a database of links that I want to always look for, and then the minute you give me the link or the route or the URL, I am able to tell you the links that should be attached or the links that should be joined with the payload for that given URL. Okay. That is a mouthful. Let's continue. Now, let's go ahead and do something with this after before and after after. So for instance, we can come here and we can say
hooks, 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 hooks.
Should they be before or should they be after? They should be after. Okay, so we're going to put these hooks in the after, and okay. Okay, so okay. Okay, so most likely touch on HOAS and the functionality of route node children. Okay. Let's take a look at the let's take a look at the Okay, so what we're doing here is we're trying to create the complete set of APIs and then see if it's possible to have like a pre-registration mechanism that takes in the APIs, and then we will look for a way to make them leverage hypermedia advantage. So we're going to go and say context.locations open, and then from heaven impulse. No. So we're going to take a look at the we're going to take a look at the create one endpoint. We're going to do a couple of mundane copy and pasting so that we can move to the next level. We've talked about this to some degree, but we need this to be complete so we can take the next step in the learning journey. Again, there are people that are just joining, and so we have to. So
Bluetooth connected.
We talked about the pseudo root type before. We also talked about the CSS variables. We specified what they were. And the founding blocks for the design system that we're using. Here we're seeing the wildcard character. The font family is responsible for the styling of font. What type of font you have on your web page. The numerous type of fonts. That's a custom glass. Sometimes you'll notice that glasses are arranged top to bottom in ascending order as you see B's before C's. Yes. Yes. Can you guys hear me? Well, There are fundamental concepts that a web application must have. These concerns or these concepts cut across multiple different things. The first one is connectivity. Every web application wants to be connected. The second is security. If you have a web application and there is no security, then chances are that you're going to lose a lot of customers, lose a lot of people. So security is an important component for every web application. Very, very important component. The third, you want to make sure that there's discoverability. Discoverability is a very, 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 very important part of a web application, particularly one where there's lots of data. So we'll be focusing on these three components. We'll be focusing on the component of one, security. Two, we'll be focusing on the component of discoverability. Three, we'll be focusing on the component of connectivity. Okay? Focusing on the concept of discoverability, which has to do with search, and then we're focusing on the concept of connectivity. When it comes to security, we had talked earlier about attribute-based access control and role-based access control. But then there are other components of security in an application that needs to be taken care of or that needs to be catered to and that cannot be overlooked in the tiniest bit. Things like, how do you store your secret key? It's very, very important. How do you store your secret key? How do you make sure that your databases are secure? What about the ports? What about the server where the application is going to run? So all of these are very, very important. All of these are very, very important. When am I supposed to take a break? When can I take a break? Okay. So, from a search perspective, there are a couple of search platforms that can be used. When you think about search, you can take a look at Google. Okay. There's Miley Search. There is Elasticsearch. There are a couple of other search engines and search platforms that you can take a look at to get yourself up to speed. There are a couple of search platforms. So, taking a look at some of these search platforms, let's explore now search platforms. So, let's take a look at Miley Search. Okay. When we're talking about search on a web platform, so you want to build search into your product, then you are better off using a library as opposed to trying to roll your own search. Okay? You're better off using a library as opposed to trying to roll your own search. If you try to roll your own search, chances that you might get it right are slim to none. And there are many very popular search platforms that already exist. So, like for instance, we have Miley Search here. Away from Miley Search, you have Elasticsearch. Okay. And these are very, very popular in their own right. There's also Algolia, that's also very popular. And then you have there's also OpenSearch, Quickbit. So there are a couple of search platforms that you can use. We're going to take a quick look at each and every one of them, and then we're going to look at the pros and cons, and we're going to pick one of them and take a look at how some of them can be integrated into a web application. More importantly, we're also going to take a look at them and say, for instance, how do you save the information or the master key that some of them might upload to you in a manner that is safe, okay? In a manner that is safe. So, starting with my research, if you open my research, you see that it is backed by a cloud company, and we have it to install. So, you can install my research on Ubuntu. You can install it on Mac, and I think also on a Windows computer. But it is a core component. So when we're thinking of every single product you build, you must have search. Now, you can have search to some small degree where you have search, and the search is search that is powered by your naive engineering practices or your naive engineering capabilities. Okay, you can have that kind of search, but the search is limited in that there is no the search is limited in that it is not something that can be used for instance, multi-tenancy. So if you wanted to build an application and you wanted the application to be a multi-tenant application, if you are building an application and you want the application to be a multi-tenant application, can you guys in the chat, can you hear me? Can you add the volume? If you're building an application and the application is a multi-tenant application, then you're going to want to use something that has some level of I'll take 15 minutes. From what time? From what time? From 20. Yeah, I want to finish what I'm saying. So if you are building an application, there are a couple of things that are very important for the application to have. So one of them is security, the other one of them is search. And of course, there are things like discoverability that also go into building an application. So when we talk about search, there are a couple of things that you can use. You most likely don't want to build your search platform from scratch. You want to use something like Elasticsearch or Search or Algolia or TypeSense. And one of the exercises that we're going to be doing would be how do you choose technologies, when do you make your build versus buy decision. These are all very, very technical conversations that need to be had. Many organizations from Zalando to ThoughtWorks, they all have tech radars, and they have all spent a lot of time training engineers to be able to make these decisions and make it with in a sensible and economical way. So when we're talking about search for web products, the search that we're talking about is most likely not the search you implement in JavaScript where you want to filter out a few records that have been returned from the API, but more so the search that you want to make. Maybe the search if it's even something that can support multi-tenancy, and it's search that is global beyond or outside what has been aggregated in the database as well. For this, you must always would want to use something like My Research. So we're going to take a look at My Research. We're going to take a look at the quick start, how it's installed, how you would incorporate it to an application like Python and or JavaScript. Is it loud enough? Want to give me this one.
Bluetooth disconnected.
So we're going to take a look at how you can use my research for this and some of the best practices. Also, we're going to take a look at how do you secure your application, and not just the security of securing your application in terms of including an authentication token for people that are authenticated to view your API. No, we're talking about how do you secure your application, how do you keep your secrets safe, how do you keep your secrets safe. This is a very, very important conversation to have. There has been one too many applications that have been compromised just because the secrets were not kept in a safe manner. And so, starting with my research, to install or view my research, you go to myresearch.com. You can install it and try it. For you have to buy if you want to. Just use the free version. I have used the free version for a very long time, and I've not seen the need to pay for a version. Maybe it's the management. It's the management. So first things first, want to install my research. Okay, take some time to install it. Once you've done that, you want to pick a language of your choice. And then once you've picked a language of your choice, you can take a look at some of the popular SDKs that exist, and you can go ahead and try to integrate using those SDKs. Another one that will be more likely good replacement, but then that comes at the price. Yeah, Algolia is quite capable in that sense, but then it comes with a hefty price, because it is not like an open source system like MyLesearch and or Elasticsearch, and many of these are not necessarily open source as much as they used to be, which brings us into a new word: open source. Open source. What does it mean when we say something is open source, and what does it mean when we say that an application? Because there are a lot of organizations that started out as open source and eventually ended up as closed source, or they eventually turned out to be copy left as opposed to. But anyways, open source. Open source is where your source code is open to the world. Open source is where your source code is open to the world. So, for instance, in the Heaven library, you say the source code is open to the world, but the Oracle database server, you wouldn't say that is open to the world. You would say that the Oracle database server is proprietary. They don't share their source code without. It has to be within the walls and the confines of the company. So it is a proprietary closed source. Closed source system. It's a proprietary closed source system. Is there anyone that has a question as to this? So open source is source that is open. You can at any point in time see the source code. At any point in time you can see the source code and you can use the source code. But the proprietary, you don't see the source code. You cannot use it and or resell it for your own purposes. Now, outside of the open source conversation, we're talking about how search and discoverability are a very important portion of an app, and we're talking about how provide a very simple avenue for you to implement enterprise search into your product. So if you want to implement enterprise search into your product, go ahead, visit myresearch.com, choose your operating system of choice. If it's Ubuntu, choose that. If it is Windows, I'm not sure if it works on Windows. If it's Mac, choose that as well. And once you're done, choose an SDK or an library of choice, and we're gonna go side by side to see how myresearch works. Okay, it's going to be the same fundamental principles as something like what do we call it? Something like Elasticsearch. And then there are a couple of other ones nowadays as well that offer some level of configurability. There's OpenSearch, and there used to be a lot of rage around things like Kibana. So, and that is because it's part of the ELK, part of the ELK stack. So, Elasticsearch, myresearch, these are the two popular search platforms for the modern enterprise. Elasticsearch, myresearch, these are the two. And I'm going to take a quick break so I can recharge again, and I will see you lovely folk in a few minutes. Who is that? Okay. Okay. So, back by popular demand. Back by popular demand. Here we're going to Okay. One of the things that we can do is to add okay. Let's go. Let's go. Now, taking a look at all the tables that are here, we're going to try to see if all the tables here have a match to the data that exists via the APIs. Okay. Starting with skills, let's take a look and see if there is a match between the tables that we've defined and the code that we've written. And if there's a mismatch, we're going to try to bring the code up to speed and then create an API and show how to create an API so that at the end of the exercise, there is no discrepancy between the code that we've written and the tables that we have identified and or created. So let's take a look at the SQL file. If you take a look at the SQL file, you'll see that, or the SQL file, you'll notice that we have skills, we have offerings, we have companies. So let's split this. Let's split this into two. We have a HTTP file lying around somewhere. So when we take a look at this, we can see here that there is okay, I got this. Okay, so when we take a look at this, we can see that we have the tokens. Now, tokens are how we control security access to the app. So earlier we talked about JSON Web Tokens, and we explained how JSON Web Tokens are not encrypted, they're just encoded, which means that if you think you can put sensitive information in your JSON Web Token, then you're on the long thing, because you're going to share your sensitive information with anybody that has a computer or has time to decode what you have encoded in your token. But what makes the token special is that you always know that you are the one that made the token. So it's more like by verification. So if I gave you an invitation letter, and I know that I gave you the invitation letter, then it doesn't matter that the invitation letter is not the best printed, the most secure in the world. I can verify that it's my invitation letter, so you're allowed to come to my party. That's basically all it is, okay? So the tokens endpoint is how we create a JSON web token, and for that you need to pass in your username and your password, then you're going to get a beautiful token. Then but there is no table for the token, even though we have a way to identify users. There is no table because you really don't want to be saving token data somewhere where someone else can take and then simulate and or use for something else. So the token data that we create, we give it to you, you either save it or you throw it away, it's up to you, but after a while it's going to expire and you need to come back and repeat and rinse and repeat the process again. Okay, so whenever you're building an application, keep in mind that the JSON Web Tokens are encoded, not encrypted, and there are actually different people that use different styles for protecting API resources. Some people don't even use JSON Web Tokens. They just concatenate a secret string, a long enough secret string, and they give it to you, and that's your key. And in their mind's eye, that is more secure because it's not something that can be decoded, and they can just use that to uniquely identify you anyways by saving your data in a base somewhere. Okay? So, having said that, let us move on to the next. We have registrations, and for registrations, you'll notice that you provide a username, a password, and a designation. The designation can be one of individual or company. You can be an individual or you can be a company. But when you're registering as a company, what is actually happening is you're registering as the contact for the company and not necessarily the full-blown company, subject to verification, of course.
So we have company or companies. Let's send the request. Okay, that works. We have the request to also create a company and the company as well as to get a company by ID. Okay, so if I remember correctly, there was a mismatch between what we have here and what is in the company's controller file. So let's take a quick peek. And if there's a mismatch, we're going to fix it real quickly and explain what we're doing as we do that as well. So let's come into the company's controllers file, hit enter. And what do you know? We have a couple of items here that are empty and have not received a lot of love. Okay? So we have at private, we have get one, and then we have update one, replace one, we don't replace, so we delete, activate one. Let's see. Let's open the company's routes. So replace one, bye-bye, replace one. Okay, so we have the company ID, and we can get one, we can get all, we can delete one, we can create one, we can update one, and we can activate one, but that should be reserved only for the people that have a designation of TBHS. So let's go ahead and import protected, and okay, another thing that we might want to do here then is to provide some data, seeing as we know that anyone that gets here already is an administrator, given the context for how we have set up the protected decorator. So we have type object, properties, company ID, location ID, and so what is required is the company ID and the location ID. Okay? Now, activating a company basically goes in the manner of identifying the stakeholders in the company and then going ahead to, so let's remove all these. Let's remove all these. And then let's talk more so towards what we want to do when we want to activate a company. So when you want to activate a company, the first thing that you're going to try to do is you're going to say, hey, I want to check okay? You're going to say, I want to check to make sure that the representatives of the company have the right to activate the company. And then we're also going to take a look at company details, and then activate by assigning. Okay, so here we have the representatives of the company have the right to activate the company and the company details. So have the right to activate the company, most likely here talking about something towards the lines of having a file or a document that can be ascertained for authenticity and or correspondence. Okay, so we need to create one more
if we want to make sure that we have all the structures required, we're going to make sure that we actually create one more. We're going to create one more table, and this table would probably just be a wrapper or a thin layer around the files that we upload. So we're going to have the information for the company, and then we're going to have metadata about that company tied to AWS S3 or tied to some sort of file management system. So we can do a quick search for a file management system. Let's take a look at what we have online when we say upload files via API. Okay, so here we have, we say we're going to take a look at file uploads. S3 versus Okay, so after taking a look, we can use S3 to store files. That's what it's built for. So we're going to take a look and see if it's tenable for single file. There used to be a platform called Cloudinary. I am not just sure if Cloudinary is okay. So let's take a look here. We have okay. Let's go ahead and take some. So because we want to use because we want to use the media storage capabilities of S3, we're going to need to download a library in our case, seeing as we're using Python, we're going to have to download Builder tree. So let's go ahead and say py. There we go. There we go. Okay. Okay, so we have installed Builder tree, which would allow us to upload files to Amazon S3. So let us continue our overview of the tables and see if there is a mismatch. So for offerings, we know we have done the offerings. For contacts, not so much. So we can go ahead and try and see if we can do that. Let's take a look. Let's take a look. We have the routes, we have the companies. A touch contact and so. Attach a contact. Another thing that we can then do is, okay, we can attach a contact, or we can attach a contact, or apart from attaching a contact, we can list all contacts. I think list all contacts, and then we go requests, we go response, and we go context, and then we come here and we pass. Now one of the things that we can do here is we can come here and we can say, we want to make this at private. We also want to make this, no, let's leave it like that, at JSON 8. And we want to add the add operations so that, and we say here, companies. Okay, so here we come and we say, okay, so here we have the list all contacts for the company, and that is bad AI. So come here, we say company ID is equal to request columns. Okay. Now op.select.limit. What exactly is this? What rubbish? Is this supposed to even be the company's contacts? Let's take a look at the SQL file and see what's actually going on. So we have here company, the email, name, phone, with. Okay. Okay. You're going to stay awake and continue teaching and coding. You love coding. Okay, let's do this. We have OP operation, companies up. We want to list all contacts in a company. How do we go about doing that? How do we list all contacts in a company? So we have the contacts, and the contact, it's a one-to-many relationship because every single contact must have a company. So to do that, we're going to list contacts, not companies. So this is going to be the contact, not company, and this is going to be contact up. But it's going to be the company ID. So we're going to come here and say up.select where company. Okay. And not company ID, but also company. So we're gonna try our weight. Okay, and so let's come here and see what. Okay, first things first. I think there is a typo somewhere making this. Okay. Not locations, but also it's never awaited, which means that we did not wait for the so we did not so wait, let's first escape from here. That's not what we're talking about. We're talking about we did not await. Okay, so we have here the companies and we have the contacts, get contacts. So we have companies 5 or 3 7 available. What's going on? We have here that so we're going to take a look at this and we say, hey, service unavailable, what's going on? Service unavailable, exception as exe. We're going to print exe and then return. So let's try that again. And able to do that. Now let's take a look and see. Okay. 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 Now we have the locations and we have the contacts that are tied to the company, but locations are not. Okay. Okay. So we're going to still have to talk about technology. It's just going to be not as technical. So I'm going to talk about technology tools. I'm going to talk about technology processes. I'm going to talk about technology in general as a lesson, but it's not going to be as technical as Python and or database technology concepts that I have been talking about up until this while. It gets to a point where you get the law of diminishing returns, and yeah, I think I'm at that point where there's a law of diminishing returns. So I'm going to go ahead and just talk about technology in general. I'll talk about tech teams. I'll talk about the different kinds of tech teams. I'll talk about product managers. I'll talk about software engineers, DevOps engineers, and I'll give lessons around software development, but without necessarily being very, very technical. Hopefully that will excite my brain back into being hyperactive again. And okay, so as a software engineer, what does a software engineer do on a day-to-day? What does a software engineer do on a day-to-day? Like when you wake up in the morning, what does a software engineer do? If you go to work, the truth of the matter is that the life of software engineering in the corporate circle determins on the kind of company you're working for. If you're working for a company that uses technology as an assister, like technology assists the primary work of the company, your life will be different from if you're working in a company where technology is the product, okay? So you have two kinds of tech companies. There are tech companies where technology is not the product. Technology helps them sell the product. So for instance, you have a company where they do
say they are a manufacturing company, okay? Or they sell stuff. And then because what they sell is super nice, it's very, very nice, everyone loves it, they can't get enough of it, they have a very nice website, and that website is super popular. They get millions of people that come to the website. They want to buy this really, really nice stuff. It could be that what they sell is even something as simple as I love rice, so they sell like a pre-made rice, and it is so popular that a lot of people go to the website to buy. Now, this kind of company, they are not a technology company per se, but because they have a product that a lot of people are buying via the website, and the website is seeing, let's say, in excess of 2,000 plus people per minute or per second, they have a team of 100 plus or 200 plus engineers or 300 or 400 plus engineers. They are not a technology company, okay? They have a team of engineers helping them maintain their technology product, but the technology product is not what they sell. What they sell is the rice or whatever it is, that the product that is so popular that people are buying, okay? So the work you do in this kind of company is going to be different from the work you'll do if the company was, let's say, selling software through and through, okay? So these lessons that I'll be giving now are more so on what software engineers do, how to go about your activities, how to be productive in an environment if technology is not the mainstay and if the mainstay is something else. Let's say the mainstay is clothes, for instance. Now I can speak to the validity of this directly because I used to work at Zalando in Germany so many years ago. Zalando is a company that sells clothes. They make a lot of money selling clothes. They sell clothes. So the 9 to 5 for an engineer in Zalando was like, don't get me wrong, they're a very technology heavy company because the website is visited by millions of people. They have thousands of engineers. They build a lot of stuff. You have RabbitMQ, you have Kafka that has been heavily, like this with Nakadi and the message streaming, thousands of messages of consumptions. They have like very, very capable data scientists, but they are not a technology first company, okay? They're not a technology first company, so the 9 to 5 in such a company is different because I have worked in a technology first company that sold technology, the product was technology, and it was a different experience even though it was a smaller company. So, lesson number 1, if you work in a company that is not that is not the primary product is not technology, then you need to be able to marry yourself to the technology component of that company, okay? Don't get lost in, oh, this company is not a technology company. Don't get lost in, oh, they sell clothes. Don't get lost in, oh, they sell shoes or something that is not related to technology. And you get so far away from the fact that there is technology in the company that you're pining for jobs in smaller tech companies according to how you see fit, okay? Look for a very, very, look for how you can marry yourself to the technology component of that company and marry yourself to it, okay? Marry yourself to it. That's the first advice, okay? Marry yourself to the technology part of the company, and that way you'll find joy even in the little things. You'll be able to take ownership for a product within the company, and you'll enjoy yourself whilst you're at it. The second lesson in such scenarios, okay? The second lesson is, just because you're not working in a technology company does not mean you cannot work on technology first products. For instance, I created a couple of open source technologies working in a company that was not technology first, or so-called technology first, you can contribute to open source. You can take a look at some popular open source libraries and say, hey, you know what? I want to contribute to this open source library. I'm going to spend my time contributing to this open source library. So this lesson, or this second part of the lesson, is how do you get started contributing to open source technologies? First things first, what is it that frustrates you the most in your current company? What is the thing that frustrates you the most? What is the thing that you absolutely hate? What is the thing that you absolutely like? If you could change it, you just would go and change it, okay? Okay, if you can find that thing, then the second job, then it's easy, your job is easy. The second job would be, what would fix it? Okay, is there an open source, and this, that's if this is a technology related problem, is there an open source tool? Is there an open source framework? Is there someone in the company that you need to talk to fix this? Okay, if there is such an open source tool, then the advice that I would give you would be, go to the GitHub page or the Bitbucket page or the GitLab page, whatever version control system you're using. We talked about version control in the earlier part of the lesson. Go to whatever GitHub, GitLab tool product that they're using, and look for the simplest task they have, okay? It will shock you that there are many, many, many products that exist, and these products exist, and maybe the documentation is very poor. Maybe the first language of the amazing, very brilliant engineer that built this product is not English, and maybe you speak better English, or maybe they're looking for a way to translate it Portuguese or Italian, and you're the guy or you're the girl. So look for the simplest way to contribute and start doing it. And then use that to work your way, because look, I know as engineers, particularly around the time of COVID, we had the feeling that programming is a solo sport. No, it's not. Programming is not a solo sport. You can do programming solo, but it is a team activity. It's like an art. It's a social activity. There is no one that has built anything that is like a truly immensely massive project that has done it in isolation. You always do it in collaboration with other people. Maybe not always at the same time, but you're doing it in collaboration with other people. So it's not a solo activity, okay? And it not being a solo activity means that you have to actually get that face-to-face with the people that you're programming with. You have to have that people aspect as well. Now, I can speak to this personally as well, and I can give a lesson on this, because this is something that I struggled with very, very early in my career. When I was first promoted to become a manager, I said, I hate management. I just loved coding. I still love coding. I am a manager right now. I love coding, but I also love management. But the first time I was promoted to become a manager, it was very, very difficult, because I couldn't get my eyes out of my computer long enough to actually see the problems that my team was having. And a few people in my team suffered for it. And then somewhere along the line, it clicked. There was always someone that gave me the ability to keep coding, okay? They were the ones that folded their sleeves and made sure that I had everything that I needed. I had all the information that I needed. I had the best devices. I was not distracted, had regular one-on-ones with me. And because they were so good at it, I took it for granted. So eventually I stepped into the role of a manager, and I love every single person that I manage in my current company. They're superb, amazing people. But if you don't warm up to the people that you work with, you're going to have a very rough time. You're not going to have a rough time because people are mean or people are wicked. Again, these are technology. We're talking technology. We're talking computers, okay? And I'm giving computer lessons. I'm giving computer tips. Not necessarily tips on coding. We've done that, okay? We've done that for a very, very long time. Over the past 50-something hours, we've been doing that. Now let's take a different approach. Let's talk about computer lessons that have to do with the actual work, not the actual work that doesn't involve you typing on a computer non-stop, okay? The work that goes sometimes unnoticed. So if you don't take the time to invest in your colleagues, you'll have a hard time. You'll have a hard time not because they're not nice people. It could be something as simple as you want to ask someone for help, but how will someone invest the time to help you? Like, they have to be a really, really amazing girl or guy to just help you when you've not actually also invested in them. It's like there was this saying where someone was saying that if you want to get promoted, then you need to know someone in the room that does the promoting. Because if you don't know someone in the room that does the promoting, the chances of you getting promoted are slim. Well, I'm not saying politic and don't work, no, but you actually have to invest in the people that you work with, okay? It's absolutely important that you invest in the people that you work with. Okay, now, that is on the one path. So, contributing to open source, you need to also worm your way into the community, okay? You need to build your reputation in the community. And it's also very, very important with all the malicious backdoors that we are finding in open source projects. And also when you take a look at some popular open source projects that used to be open source and are no longer open source. Case in point, we had Redis more recently, where there was a gradual takeover and anti-res. Like, it's a long story, not worth going into a rant over, but now there is Valkey, okay? Now, communities that are built around many open source projects, you obviously have people that care about the problem, because remember we said the first step that you have to take is identify something in your current day job that just pisses you off, okay? And then take a look at what you need to do to solve it. If it's an open source technology that you need to contribute to, then go and find the simplest thing that you can do. So the same way it pisses you off is probably the same way it pissed someone off maybe 6 years ago when they found that, when they started writing the code to solve that problem, okay? And if you also want to get support for your open source product, the same way you're pissed off that you go to solve the problem by writing code, you can actually go into HackerRank and many of these forums and say, hey, this is something that happens to me, and I really, really don't like the fact that there is nothing that actually solves the problem in the way that you're solving it. Maybe there are people that have solved it and kept it in their private bedroom, living room, I don't know, and you could get someone to share some amazing code with you, or you could just make a friend. But that is one of the quickest, easiest ways. You can contribute to, just because you're in a company where the primary product is not tech, doesn't mean that you can't contribute to primarily tech products, okay? You can still do that. That's the first part. Now, the second part is more around what does it take to be a productive engineer? What does it take to be a productive engineer, and what is the ideal relationship that you should have as an engineer with your product manager? Like, are there lessons and tips away from technology and coding that can help you to be a better engineer? I believe 100% yes. As a matter of fact, I will not name names, but I will speak about an individual, super intelligent, super smart. Actually, a couple of individuals that I have managed more recently, and always doubting themselves, but super intelligent and super smart. And the more that we interacted, and the more that there was the reaffirmation that you can do this, you can do this, you can do this, there was no increase in skill, none, yet, okay? But it's not true that there was no increase in skill. There was some increase in skill, but not to the point where the value and the level of work that you're doing is so visible and so inspiring in the way that it is right now. And I give them feedback about this all the time. So what I'm trying to say is that many of the things that will make you improve as an engineer wouldn't necessarily come from the code that you write, okay? We have spent a lot of time talking about Python. We have spent a lot of time talking about JavaScript. We have spent a lot of time talking about HTTP, hypermedia as the engine of application state, how it means that your APIs are very descriptive. We spend a lot of time talking about how to make APIs that describe themselves, how to have full representation for your API product, and all that is wonderful. There are so many workshops and there are so many that talk about these things, but I think I'm super happy that it's at the 53rd hour that we are going into a lesson that is not dealing with the hands-on, but more dealing with the contextual space of being an engineer. And these are lessons that usually are reserved for people in my team when they come to pick my head or when they're trying to ask a couple of questions, or I'm helping them navigate some feelings that they might be having around the work that they are doing at a particular point in time. So I do think that they are very valuable lessons. I actually do think that they are more valuable than the lessons where you're writing code on a computer, because you can get lessons for writing code on a computer on YouTube. You can open YouTube right now and then you get lessons for writing code on a computer. If you open YouTube, like you can get that, okay? And chances are you can also get something close to this, but it is rare that you get something that is a mixture of both, because we've done intense coding, intense lessons around technology. We started from HTML, entered CSS, entered JavaScript, entered Python, back to HTML, and now we're talking shop. Okay, now we're giving lessons about being a software engineer, okay? Now we're giving lessons about being a software engineer. And thank you, Adams, for the suggestion to go to something less technical. I had to dig deep for this one. So before we continue, I'm going to leave a few seconds for someone to ask a question, and in the absence of a question, we will move into talking about the dichotomy between product management and engineering proper. There are no questions, then we can continue. Okay, so we talked about the lesson number 2 being around how do you work with product management as a software engineer. Okay, lessons on how to work with product management as a software engineer. I think the first thing that needs to come to mind in this regard is separation of concerns. Okay, imagine you want to build a car and you go meet a tailor and you tell him, hey, can you build a car for me? You're probably going to get a 3-piece car, okay? And then you want to get a 3-piece suit and you go meet an engineer. You're going to get a very well engineered but ugly contraption for clothing. But on a more serious note, the job of the product manager and the job of the engineer are side by side, but focused on different things, okay? As an engineer, this is the analogy that I think makes the most sense, and I hope that this lesson translates even deeper. Think about it. War is a terrible place, okay? War is a terrible thing. But think about it like, imagine yourself as an engineer being a soldier at the battlefront, okay? Yourself as an engineer, you're a soldier on the battlefront. You as a soldier on the battlefront, you know how to shoot the most, okay? You know how to shoot the most. Now, the job of the general is to make sure you keep getting bullets, okay? If the general had to go to the battlefront to shoot, you probably would lose the war because he's not the best marksman, you're probably the best marksman. So your job as an engineer is because of your technical capability, okay? So play to your strengths, play to your strengths. And the relationship between engineer and product manager is usually where you as an engineer, you can challenge your product manager from an implementation. The simplest way to go about this is this. The product manager wouldn't tell you how to build it. He will tell you what is to be built. You as the engineer are the one to say how. So if you find the product manager telling you how and you find the engineer telling you what, then you're in a very, very dangerous place, and then you need to take a few steps back. Obono Mike says, can you tell us how to host the build project? Yes, 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 yes. Now, as it regards software hosting, there are a couple of ways to get your artifacts to production, okay? And just shy of writing on my computer again by myself, you can use Docker, okay? Docker is a container. Think about it just the same way you have shipping containers and you use them to move goods all around the world. You would use Docker to move your code from your device, okay, to ship, and that's why it's a beautiful analogy. You would use Docker to ship your code from your device to the device on the cloud or in the cloud that you want to run your application in, okay? You could use Docker to do that. And for some languages, like Python, where you don't build in the sense of compiling and building, you can build in the sense of, with Docker, you're pulling in the necessary things that you have to aggregate or assemble for your application to run live. And one of the things that I was talking about earlier, I think about an hour or 2 hours ago, when I was super tired, was that there are a couple of things that every application needs to have, particularly if you're talking about an application that should be in production. Number one is security, okay? And we're not talking about security that has to do with the authentication token that people must be authenticated before they use your app. Nope, not that. We're talking about the actual security for things like your secret key. Where do you save your secret key, okay? We're talking about security like the API keys. How do you deal with the security of your code base, okay? How do you deal against malicious actors? What about the logical security? And a couple of other things as well, like an application must be secure, okay? It must be secure contextually, logically, and in every other aspect as well. So you want to have secure applications, okay? That's one. And there's a lot more to security, of course, than just that. What about the hashing algorithms that you're using? What about the kinds of encryption or signing or encoding and whatnot that you're using? Are you using things that have been severe vulnerabilities? Have you heard that there has been an O-Day or not O-Day, but there's been an exploit, and then you leave it, you fold your hands and say, yeah, it's not going to happen. How many people intend to exploit this anyways? Okay, so there's a lot more to security than just that, but it's one of the things that you need to have in an application that you want to release out into the world. Security, security, security. It's super important, absolutely necessary that you think about the security of your applications, okay? Because whether you like it or not, there are going to be people that want to break into your application anyways. Not that they value what you have kept in your application. It could be that they value the data of your customers, so they want to come and steal the social security number, or if one of your customers called Caleb likes to see cats drink milk. They want to go there and then get all that data. Okay. It could also be that the data is useless to them, and they just want to go in there so they can take your farm of servers and use it to mine crypto, or they can take your farm of servers and use it to launch an attack on somebody else. So basically, they slave your devices for their own use. You pay the money to AWS, they use your AWS instances for their own gain, okay? There might be numerous reasons why an attacker could attack your product. It could just be like they visited your website and they hate your logo, okay? Or the attacker is having a bad day. He just broke up with his girlfriend or his boyfriend, and then they go to your website and then they see your face and you remind them of the partner, and then they just say, let me strike, and they hit your website. Like, it can be for any reason. You can never really tell. So security, 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 okay? Now, the second thing that you want to make sure your application has, you want to make sure your application is extremely discoverable. I can't say this enough, okay? Discoverability is very, 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 very important. Imagine you have built the best thin since sliced bread, okay? You've built an application that is immensely, like absolutely phenomenal, but it's in your back pocket on your phone and nobody's using it. Like, it's not phenomenal as far as like, it can be the best thing since ChatGPT. It allows you to scan into the soul of a human being and tell you what they're going to do in the next 5 years. But if it's in your back pocket, it's useless. So you want to make sure that your application is discoverable, okay? Now there is internal discoverability, and then there is external discoverability. External discoverability is where your application, we're talking things like search engine optimization. When we were talking about HTML, we said that your application is the way you structure your web page, okay? The way you build your web page goes a long way. The way you build your web page goes a long way in determining how visible it will be, okay? Google has something called the page rank algorithm, okay? We can take a look at it. Sometimes they're cryptic with it. Sometimes some people swear they know how it works, and they'll give you the best rank on Google. But let's say page rank algorithm. I didn't even have to go far. There she is, okay? Now the page rank is a link analysis algorithm, and it assigns a numerical weighting to each element of a hyperlink set of documents, such as the World Wide Web, with the purpose of measuring its relative importance within the set, okay? Now, there are a couple of other things as well that Google puts into the soup that they use to determine how discoverable your website is going to be, because whether you like it or not, they are the biggest names in search right now, and as such, many people, it's like, there's a saying that if you want to know how well made a product or a company is, it's when they become a verb. So say Google it, okay? They're not the only search engine, okay? But then they say Google it, okay? No one says Bing it. Sorry, Yahoo. Sorry, Microsoft. No one says Bing it. They say Google it. Like, Microsoft has a search engine, but I can't remember the last time I actually even remember that Microsoft has a search engine. I would rather much use DuckDuckGo than go and use Bing, okay? Now, they are the #1 search engine, so you have to play by some certain rules, write some blog posts, and this is a lesson now that slightly steps away from the more technical, nuanced parts of it to more about discoverability from a place of marketing. You want to write a lot of blog posts, okay? You can go on LinkedIn and then write something on LinkedIn, make it open, Google will crawl it, go to your website, and say, oh yeah, we found a link that goes to your website. You wrote it, but Google still crawled it and went to your website, so it counts for something. You can call your old childhood friend and say, hey, I heard you have a website. I want to post something there. And then, again, you build some credibility because your website starts gaining traction, you can open a Medium account, blog, and your website is going to gain traction, okay? So there are numerous ways to drive traffic organically and make sure that your search engine ranking is high, okay? So discoverability is super, super important. But this is only, like, now we're talking about external discoverability. There's also internal discoverability. So let's imagine that you've built a website or a web application, and the web application is extremely capable, okay? In that, or extremely affordable, in that, like, when users go in and they want to create a product, the minute they click on create a product, before they even type anything, the product is created. It reads their minds and it creates the product for them, okay? Now, a user loves creating products so much that they've created 10,000 products. But now they have 10,000 products and they can't find anything because internal discoverability of your site is rubbish, okay? So internal discoverability also counts as well. You want to make sure that search, again, I'm going to say this for the people in the back, you want to make sure that search in your website or in your web space is top-notch, okay? You want to make sure that it is top-notch. People should be able to find things. You don't want to frustrate your users, because if you frustrate your users, your competitors will not frustrate them, and you know what that means, okay? So internal discoverability counts. You want to make sure that you can find things. That is why nowadays you see that there are a lot of companies investing in making sure not just that the things in the product can be found, but even things outside the product as well. So for instance, for the company that I work for, there is I am in the developer enablement space. That means that my job is to make other software engineers happy. It sounds like a terrible job, but it's actually a very wonderful job, because software engineers are the easiest people to please. I mean it. Like, they're the easiest people to please. Like, everyone knows they're so easy to please. But anyways, jokes aside, and the reason why this developer enablement and software satisfaction field is blowing up nowadays, if you take a look at the job market, it is usually, like, you see, like, the decrease in the time that people spend in companies. That's one, okay? Number two, your customers can't love you if your employees don't. Like, there is absolutely no way your customer will love you if the people that work for you don't love you. It is impossible. It is absolutely, if everybody that's working for you hates your company, your customers are going to hate you. You can count on it, okay? Your customers will hate you so much. So if you want your customers to love you, you better make sure your employees love you, okay? If you want your customers to love you, you better make sure your employees love you, okay? So you want to make sure that the internal discoverability, and that's one of the things that frustrates people is, like, you go into a new company, you don't know what you're supposed to do, you don't know how to find information on what you're supposed to do, you don't know who your manager is, you don't know, like, it's this, like, discoverability is terrible. So you have discoverability in products, discoverability in processes, and it goes on and on and on and on, okay? So you want to make sure that discoverability is top-notch. And that is why, again, many organizations are investing in making sure that their employees love them, because, like we said, if your employees hate you, your customers are going to hate you. You can take it to the bank. If your employees can't stand your organization, like, you'd probably go into your office one day and you see a goat on your table that has pooed and urinated everywhere, and you, like, there's no way your customers can love you, okay? So that's the second one, okay? Discoverability, discoverability, discoverability. The first one we talked about was security. We didn't touch it a lot, but it is super important. Yeah, I remember once I worked for a company, I won't mention names, and there was a data breach. Thank God I wasn't well, I'm not happy there was a data breach, but I wasn't even remotely involved in the team, the department. But I was still unhappy because it's a company that I work for, and there was a data breach. That affected our sales and the confidence that our customers had in us like crazy. Like nobody wants to hear, well, you see, the thing is, the pictures that you posted on our product is now being sold to people in China. Well, the good news is we've blocked the product and they can't steal pictures anymore. The bad news is the pictures are in China. Like, nobody wants to hear that. There's absolutely no one that wants to hear that, okay? So security is super important. And like, look, as a software engineer, you can use the best algorithms, okay? Today we're talking, I think when I was, my mind was super fried. Who was it that said something about the password? And I said, yes, we're going to use Bcrypt and to hash our password. Like you can use the best, okay? You can have multiple passes and make sure that it is extremely difficult for someone to crack or to guess the passwords that you have. However, even with the best security, all it takes is for one jolly good fellow to come along and introduce a leak into your system, and Bob's your uncle, okay? So it's not just the code you write that is going to make your application secure, it's also the practices that are at play. It's also the rituals you have. It's also how well educated you are and your colleagues are. Social engineering is actually very, 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 like, sometimes you don't want to be, nobody wants to be a terrible human being. Nobody wants to be disliked. So you're walking in and someone says, please hold the door for me. And you say, oh, sure, and you open the door, but they're not an employee in that company. And you open the door for someone to go in and maybe take a laptop, sit down at home and download things. They didn't need to hack. They didn't need to do anything. They just walked in and picked the laptop, okay? So security, 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 discoverability, discoverability, discoverability. Now, these are two very, very important things, okay? So again, let's come back to the question. Ogbonna Mike, how to make your search top-notch? Show us a practical application of this. I love Ogbonna. Okay, Mike, keep bringing the questions. Absolutely love it. Okay, so I'm going to answer the question on how to build, host the build project, and then we'll come back to this. Okay, so you can use Docker. Okay, nowadays there's Kubernetes, and you have things like, of course, you have Terraform, HashiCorp. Tons of products. I used to love Console. Console is like a beautiful, wonderful discovery tool. Like back in 2017, I think I was using it, and I absolutely loved it. Absolutely loved it. Now there are so many service discovery tools and products. But yeah, Terraform is all the rage nowadays. So there are numerous ways to take the code that you have written and push it to production. There's the good old way of writing the code and then going into the server, SSH into the server, configure the server, or write a script and then have it, when you push to GitHub, you can use GitHub Actions and whatnot. There are many ways to go about it. The simplest, easiest, less stress-free way that wouldn't break bank is to use Docker. Because the minute you go into Kubernetes engine, even if you're on Google Kubernetes Cloud, okay, or you're on you're on the Google Kubernetes engine, or you're using the Elastic Kubernetes EKS, which is from Amazon, it is expensive. Just like having, like, enabling Kubernetes. This is even before you start talking about pods, nodes, and whatnot. You're going to fork out a lot of money, okay? But if you're using Docker, you're not going to spend as much money. Like even Lighttail has a power times like you can use, and you can just deploy your Docker containers, and you can put your Docker images, and it's not going to cost you too much money. And you can go you can go pretty far if you use Swarm, okay, Docker Swarm. Like it will take you almost there, but yeah, your mileage might vary. So coming to the question on how to make your search top notch, show us a practical application of this. You want me to write some code again? and I'm running away from writing code because I've been writing code for almost how many hours? Okay, so let us take a look here at Miley search, okay? You don't want to write your search functionality, like, don't do it. Just don't, okay? Like, there's so many things that you can use, and no one has paid me. I wish Miley Search paid me. Miley Search, if you want to pay me, I'm available. I don't run away from money, so if you want me to keep promoting you, hello, I'm here. Anyways, if you go to Miley Search, and then you click on pricing, like you can use the cloud version, okay, or you can just download the product like me. Like I don't have marketing dollars or funding from someone that would make me just willy-nilly pay for stuff. I would rather download and use on my computer until I absolutely need it, and then yeah. Or I would even just provision it on a cloud instance myself. I can pay $5 for Linode, but I can't pay $50 for something else. Like, it's just me. Maybe I'm cheap like that when it comes to things like this. Maybe, I don't know. Okay, so, however, that is not true. There are times when you absolutely want to pay for a managed service, okay? Don't take my advice, because many of the things that I am doing are hobbyist projects. If I have a hobbyist project and I'm working on something, I won't go pay $60 because I have a hobby. There's no way I'm going to do that. Like, I'd put $60 into something else. So, but if I have a product that I'm building and I want, like, paying for managed stuff takes away a whole lot of stress. Imagine you pay for managed database services. You don't have to go and start fine-tuning and then configuring if it's Postgres or MySQL or whatever. Like, you don't care about none of that. You pay, and then it's someone else's headache. It's someone else's problem, okay? So, depends on where you are. Your mileage might vary. So, come in here. If you type here, okay, if you say, you see, immediately I say hello. It's like, it gives you it's super fast, okay? And the beautiful thing about things like Miley Search and He Who Shall Not Be Named, okay? They used to be number one, Elasticsearch, and I think they still are. I'm just like, but yeah. Elasticsearch, Miley Search, there's Algolia, there is OpenSearch, there is, hey, every single person I've named, I'm happy to collect money from you, okay? So there are a couple of them that you can use, and you don't have to build from scratch yourself. I think Algolia is even, and TypeSense. How could I forget TypeSense? Hit me up, TypeSense. So some of them even have like the whole AI integration. They make it like, AI is all the rage nowadays, okay? So, and many of them you don't even have to do anything. Like, they take care of everything for you. But Miley Search is something that is a product that I have loved using recently. Like, I absolutely love it. I also love Miley Search because it supports multi-tenancy. Now, what is multi-tenancy? If you are building a web application for businesses, chances are you are going to get to some point where you want the data of your customers to be separated, okay? As a software engineer, there are numerous stories and instances of someone mistakenly forgetting to select from the database where account is equals to, and then fetching the account for some other customer and then giving it to another customer, okay? So there are multiple approaches to this. If you're using something like Postgres, you can use a schema, and then you create a schema, and all the customers, their tables are in a different schema, and so it's very difficult for you to say, oops, I make the mistake, and then the data for customer A went to customer B, because you must explicitly specify. And another strategy you can use for multi-tenancy is you can use subdomains, okay? I know Workstation uses subdomains. So what you can do is you can say, for instance, molly.workstation.ng, and the only people that will be able to sign in here are people that have a Molly, like Molly, okay? It's not like workstation.ng slash, and then there is you sign in, and then it's like, no. It's like there's a subdomain, and then so you have a subdomain, even from a cookie saving perspective, cookies will not travel across subdomains. So you're much safer. Like there's security, multi-tenancy, you're much safer. Okay, that's nice. I can see, but there's no echo. Beautiful. So the idea then behind multi-tenancy is that you have your customers' data and they live in different buckets. Miley Search allows you to have true multi-tenancy support in your search. So that's why I like Miley Search. And a couple of them also do as well, but yeah, I like the way Miley Search implemented it. So if you want to have top-notch search, I would recommend you use this. I've given you a practical application, and you see here where we're searching for movies. Let's also imagine that you want to search for pepper, okay? And you type pepper, and there's someone in your company called Pepper. There's a fruit called Pepper. There's a house called Pepper. There is so you will see all the categorization, like this is for human beings, this is for that, this is for. Usually you would have to write like some serious amount of code to be able to get that level of functionality. Like, okay, this is perhaps the best argument I have for someone using some of these things, okay? Many of the open source products that we use as engineers, it has thousands of man hours behind it. Imagine, think of it like a company called 100 engineers and paid them a lot of money and told them to build a product, and then you get to use it for free. Okay? So you have thousands, hundreds of man hours that has gone into something. You're not paying a dime for it. It's like you basically waltzed in and picked something that the company paid for, and you're using it for free. So why won't you use it? Like, yeah, but anyways, maybe you like building things from scratch. Go ahead. I'll see you in 2050 when people are using flying cars, maybe. Okay. So I thought Ogbonna was going to keep the questions coming, but yeah, thank you, Ogbonna. I really appreciate it. Beautiful, beautiful, beautiful questions. So from there was a conversation we were having earlier around the product manager and the software engineer, okay? The product manager doesn't tell you how. The product manager will tell you what, okay? The product manager is the one that's going to say, look, customers absolutely hate our product, okay? These are the things we need to do to salvage, okay? We have a lot of churn. Like, churn is when we say that it's like the English term, okay? People are leaving, okay? People sign up and then there's a lot of drop-off, okay? So in tech speak or in tech product speak, imagine you have a huge pipeline. Lots of people come to your site as a result of maybe marketing dollars or organic, or your page rank, your Google search engine is top-notch, or for whatever reason. But then you notice that at some point, there's a drop-off. Like, so many people are leaving. Maybe they leave before they sign up. Maybe they leave after they sign up, okay? But there's a drop-off. And then you see that, okay, maybe there's a drop-off of, let's say, 10%, and you say, okay, that's good. But then for all the people that pay, less than 1% of them come back. That is a serious problem. It means that you're selling dog poo, okay? So you better find out what the dog poo is, or you'll be sitting at home literally picking dog poo, okay? So the product manager is the one that can come and tell you, people hate us, okay? They hate us like we suck, okay? Now, there are lots of reasons why you might suck. You might suck because as an engineer you suck, which is very, very rare, okay? So you built a very crappy product. And I have seen a lot of crappy products in Nigeria. And my brothers, and they know. Like, sometimes I open a product and I'm like, goodness, is someone making money from this? And they're like, you are a perfectionist. You try to build things to perfection. But there are tons of crappy products, and usually when you go and see a product that is just beautiful, it embraces you, it hugs you, it pampers you, and you don't want to leave, okay? So the product manager is going to tell you, people hate us. It's not your job. So if you're an engineer, okay, you can help your product manager, but it is like you're not the one that will say, this is what we're going to build. This is what we're going to do. This is what we're going to do. That is not your job, okay? You're the one that will say, this is how we're going to do it. The product manager is saying, this is what we're going to do, okay? We're going to drop this functionality, and we're going to drop that functionality, and you'll be like, okay? This is how we're going to drop the functionality. If the product manager starts saying, well, you're going to write code like this, and then you're going to go like, that is not his job, okay? That is not his job. So the product manager will most likely tell you, this is what we want to achieve, and then you're the one that has the best technical skill to be able to interpret the technical implementation of that. Are there any questions? Merci beaucoup, merci beaucoup, merci beaucoup. No questions, no questions, no questions. Okay. So let me stop giving my research marketing time, and let's move back to our code base. Okay. Now, there are also a couple of things that can be said around technology, particularly when it comes to build versus buy. Now, many engineers, if you take a look from Zalando, this is the second time this evening I'm talking about Zalando. Like they had a really nice canteen, a very nice restaurant, like very, very nice restaurant. Now, from Zalando to ThoughtWorks, many companies are investing in something called the tech radar, okay? What is the tech that we use? How do you choose tech? And things like this, okay? How do you choose tech and other similar questions? They want to make it easy so that engineers don't have to deal with distracting thoughts or things that will take their mind away from being the productive technical ninjas that we are, okay? So there are a couple of ways to go around this. Now, I think maybe one of the questions I've had the most is, why would you use a specific programming language over another programming language? And the younger you are in your career, the more you think that Java is the best thing since sliced bread. Like, oh, I would get married to Java. If I got married to my wife and she doesn't speak Java, I'm going to divorce her on the first day. Like, people are so attached to technologies and so attached to specific things that it's just like, but I don't know any billion-dollar startups built in Java. I'm not saying that there are none. That's not what I'm saying. I'm saying I don't know any billion-dollar startups built in Java, built in Python, built in Node.js, it doesn't matter. Like, there are companies that are worth a lot of money, and they were built in JavaScript that a lot of people piss on and hate on all the time. I don't have a problem with JavaScript, okay? And there are a lot of billion-dollar companies that are built in Python that people piss on and hate on all the time. I could give you one, for instance. YouTube is built in Python, at least the last time I remember. How many people know YouTube? Like, YouTube is built in Python. So the language doesn't matter. Like it really doesn't matter. Okay? What matters is the problem you're trying to solve. That's what matters. Okay? What matters is how soon you can get a working sample in front of your potential customers to verify the plan, your idea. That's what matters. What matters is how soon you can get the traction if you want to get investors. That's what matters. So when it comes down to choosing things like database technologies, don't choose a database technology because you heard MariaDB was good or Postgres is free, or, I mean, if something is free, choose it. If something is free. But on a more serious note, don't choose a database because you had, oh yes, this is good for this. Your use case might be different. Your story might be different. The thing that you want to do might be different. Sometimes it is better you use a NoSQL database or a graph database. ArangoDB is good. I like ArangoDB. Like there are people using ArangoDB. Hey, ArangoDB, you want to give me money? I'm up for it. Okay? The MongoDB is good. There's so many nice databases, okay? But there are times when I wouldn't use ArangoDB even though I like it, and there are times when I wouldn't use MongoDB even though I like it. There are times that I wouldn't use Postgres at all, even though it's like my favorite relational database of all time. So you want to choose technologies based on the problem space, okay? Look at it this way. You go somewhere and they tell you the problem with this place is that it is too hot. It is just too hot. That problem space has heat. And then for you, every problem space you go into, you come wearing a thick cardigan so mosquitoes can't bite you. And then your hair is too hot, you still come with that massive, thick cardigan and you go in, you'll die of heat. Okay? You need to say, okay, this place is too hot. How can I go in here and still be like, okay, maybe I need to get a mosquito net. Okay? So that I can sleep in the mosquito net and then the air and whatnot. Like, maybe I need to. So the problem space will determine the technology you use, not the technology determine the problem space you go into or the kinds of things that you do. Okay? So that's another thing that I think I wish someone told me this when I was a younger engineer. Like, I really do. Like, I would have, like, by now probably I would have made more mistakes because they told me all the mistakes not to make. But on a more serious note, these are lessons that, in my opinion, are even, like, these are computer lessons that are even more important than the, if you type like this and you do : -1, you're going to reverse a list in Python. Like, and that's fun trivia to know. Like, it's really fun trivia to know. Okay? But there are so many things that you need to know to be successful as a technologist in today's world. As a technologist in today's world. So, like, these are some of the lessons that I think are not mainstream. Another thing that I realize is that, and like this is another lesson, is we don't see the diversity of technology. Okay? Technology is very diverse. You cannot be the master of everything. You cannot be the best database administrator and the best software tester and the best software code writer and the best DevOps engineer and the best Linux professional and the best networking professional and the best cybersecurity specialist, and like, come on, it's not possible. It's practically impossible. Technology is like, I know a woman that makes enough money to stop me from working for the next 10 years. And for the next 20 years. And she doesn't even write, like she writes in like an old, I think is it Fortran or Kobo or something, like one of those, like, it's just like, she has specialist knowledge, and she's like, so it's so vast that it's possible that maybe the Fortran you learned when you were in the school in Nigeria and you were insulting the university that they're teaching Fortran when people are using Golang and Rust. You'd go maybe to Germany and then they tell you, yeah, well, our system is in Fortran, but there are like only 3 people that can fix it. We'll give you 500,000 euros a year. If you hear that kind of story, please remember I'm your best friend, okay? Call me. I'll be happy to be with you in Germany and give you moral support. But technology is vast. It's a very, 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 very vast field. And there's a lot that you can do, and there's a lot that you can specialize in. There's a lot that you can specialize in. So you don't have to be gung-ho that I must be a software engineer, and that's what I was trying to say earlier. It's not what I'm teaching that should inform what you become. It is what you want to become that should inform what you pick from any teaching, okay? It's not that, oh yeah, I became a programmer because someone was teaching free Python and then I took a free Python course and here I am. No, that's not how it should be. It should be, I want to be a cybersecurity specialist. I want to be a cybersecurity specialist, and like, I'm not giving career tips because this is a lesson, okay? It's not career tips, it's a lesson. Like practical computing lessons from my experience as an engineer over 15 years. And when I was studying data science, my friends were laughing at me in university. When I was studying data science, they were like, ha, 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 ha. Studying data science, come and do software project management, ha, 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 ha. Come and write code with us, ha, ha, ha. And look at data science right now. Like, it's ridiculous, okay? And even back then, there was the notion and the story that our professors kept telling us, like, this is going to be big in the future. Study it. Like, they were telling us back then, this is going to be big in the future. Study it. So it means that even right now, there are people in your industry that know what the next big thing is. And so you should be trying to get in close proximity with those people as much as possible. So take your head out of code, okay? Look around once in a while. You don't know. You just might fall into a Bitcoin mine, okay? So these are some of the non-programming lessons that I wish I could have learned. I would have paid top dollar to learn it. I would have paid like serious top dollar to learn it. And there's also, away from the work of being a software engineer, there's also things like interviewing, okay? Things like, there was a time when I had a lot of fun in my life, and I was like, hey, I'm hot sauce. Everyone wants to hire me. And then I work here for a couple of months, and then someone comes and says, we're going to increase your salary by $10,000. And I said, oh, yeah. But like, I always had a reason for leaving. Like, maybe I was leaving country, okay? But if I were deliberate, I would have stayed in the country. Like, well, I couldn't be deliberate because I had to leave, but when you grow and you want to hire, hiring managers want to look at your stability. They want to look at how long have you stayed as an engineer, okay? And what problems have you solved as an engineer? It's not that I worked in this place, no. What problems did you solve? What impact did you make in that place? So, if you don't take anything away from this lesson today, take this away. You absolutely have to make impact, okay? You absolutely have to make impact. It is absolutely necessary for you to make impact. You don't have to be the brightest in the room to make impact. You just have to be hungry enough to want to make impact, and you'll make impact. Like, I have seen this happen over and over and over and over. As a matter of fact, the bright kids, like the people that programming comes easily to, I have known a few, and they're like intelligent. if you put us together, they probably would code around me whilst they sleep, but they didn't make as much of an impact when we were in the same company. I don't know why, okay? I could guess, but I don't know why. But they had better programming skills than I did, but when you juxtapose the impact and the reward that I got from promotions and whatnot, they didn't quite get it, okay? So it's not about your programming prowess. Many times, as tech people, we get lost in the technical bit of it. So I'm super happy that after 54 plus hours, we get to dial back a bit and then talk more around the peripheral lessons of it before we go back into the tech bits of it, okay? So super, 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 super important, okay? Then something else that I wish that I also knew, when you are young, or when you're starting out as an engineer, it's not the first company that gives you a job that you work for, okay? Now, this one it's very, very important because it is the first company that gives you a job that excites and motivates you as an engineer. Not the first, because I know people that started out as engineers, but now they're project managers or doing something else. Like, I know a lot of them, but they had the capacity to do it. It's just like there were so many things that happened. So again, I'm hammering maybe on the same topic. You have to be absolutely deliberate with what you want to do, where you want to go. Don't just jump on the bandwagon. Once you know what you want to achieve, start taking steps towards it. Like, you don't even have to spend 2 hours every day writing code, okay? As a matter of fact, you can spend the time you should be writing code reading a book, and then occasionally write code, you'll be fine, okay? It's not like code will just, you'll be working something and then code will just and fall out of you and say, I'm not going to work with you anymore. Like, once you've written code well enough, it stays with you. It's like speaking English. Once you've spoken English to some point, like it's a part of you, okay? Then you need to start working on the things that are not particularly around the things that are not more so in the direct technical realm, so that you are a more all-rounded engineer. You're a more all-rounded engineer. So, I mean, I have spent a lot of time writing code. I have spent a lot of time, like, if anyone, like, I have spent a lot of time writing code. But the moments that made me a better engineer were the times I was not writing code. It's a crazy thing to say. It's a very crazy thing to say. The moments that made me a better engineer were the times when I was looking at technology happen, participating in a technology conversation, or being part of something like where I heard people say something and it's like something just fell on my head and it hit me. I was like, oh wow. And it was like a moment of epiphany. It's like, so at some point it's as if you're looking around and then you realize that there is a method to, there is a pathway that anyone can hop on and get the same results. I hold my peace. Questions? Questions? Any questions? Two more minutes. When is How many hours now? We have up to 5 minutes break. I have up to 5 minutes break. Questions? No questions? We can continue then. The computer is a very fascinating tool. It's a very fascinating tool. I mean, I know I give the computer flack a lot of times, and I say the computer is it's a very dumb machine. Because it is, it's a dumb machine. It's like a really dumb machine. Nowadays with AI, we're trying to make it smarter. We're trying to make it more than it can be. We're trying to say, live your best life, computer. You go, girl. You can be anything you put your mind to. Okay? That's what we're trying to do now with AI and whatnot. Okay? But the computer is really a fascinating device. I mean, one single device has changed the course of human history in ways that are difficult to fathom. Are difficult to fathom. Now, I was talking earlier and I said that many people don't realize how vast the field of computing is. Do you know how difficult it is to be a network engineer? You can actually, it's like network engineering is a wonderful field. Like with right now, there are about 50-something people online with computers in different parts of Africa and different places, and we're all talking, and it's an amazing feat of engineering, both from a software and a network perspective. It's an amazing feat of engineering. So the computer is a very capable device in that regard. It's one of the things that I'm hoping that this lesson would also transform is like the knowledge about computers enough to fast track or facilitate like emergence of data centers and like technology-led ideas on the African continent. And I want to talk about data centers for a little bit. When we talk about computers, for instance, now if I said computers, we think about this MacBook, we think about maybe the Dells and whatnot, and we would leave things like the phone and the tablet and a couple of other things. But these are also computers. They're also computers. So at the end of the day, I think if anyone can align and get computers to like in bulk to Nigeria over the next couple of years, I think they'll be a billionaire. because this is the generation of computer literacy is just around the corner. We were not the computer literate generation. We are not the computer literate generation. There's a new generation of computer literate children that are coming. It's like, I look forward to it though. Have you calculated it? 5. How many? Okay, so I like the questions by Ogbona in the chat. Are there any questions? Are there any questions around technology? Are there any questions? A lot of time was dedicated to Python, but there wasn't enough focus on conditional statements. You mean like if we focused on conditional statements, will you feel better? If we focused on them. You know, you get a joke. Beautiful. You know, the reason why people like there's a whole conversation I had many years ago, and I'm really hoping and I'm really praying we can ask questions that would pull out experiences that are really, really like valuable, like experiences that are more valuable than a coding lesson. So we had someone come to the office, and I think we paid them like 100 and something million naira, which in today's money should be like maybe 300 million naira. And what we paid them for, it was not me, I don't have, like, it was the company back then, okay? What the company paid them for was to come and talk about the code that I complained about that we needed to make better. So they said, no, you're complaining too much about it, let's go and bring a professional to come and talk about it. And the person came and said the same thing that I said and got a lot of money for it. And I was very unhappy. Because I was saying the same thing, but I didn't get any money for it. So I complained, and then somebody got money for my complaint. Yeah. But one of the things that they said was that there is a lot of cyclomatic complexity. And then I realized, while I was complaining, I never said cyclomatic complexity. So nowadays, I say cyclomatic complexity every time I get a chance. So if introduces cyclomatic complexity, I hope you give me the money to come and, you give, okay. No? Okay, so, but on a more serious note, if you take a look at the way code is written nowadays, you will see that you hardly see a lot of if statements. You hardly see a lot of if else, if then, if, like you hardly see it. And I'll show you, and we can talk about it here. So let's open this, let's open here. Let's open app. Like you see that we have a multiplexer where if this is matched, then it goes here. This is matched, it goes here. This is matched, it's like you're not seeing any if this, then this, if this, then this. Because if you have 100 of those ifs, then you have 100 reasons for your code to go in 100 different directions, okay? If you have 100 ifs, you have 100 reasons for your code to go in 100 different directions. Don't quote me. Okay, you can quote me on this one, okay? Now, the thing is, and that's why I was saying that as much as possible, I would recommend you use a dictionary instead of using an array, because a dictionary, you can just say, give me this key, and you get it. You don't have to start doing a lot of ninjutsu to try and find, like, you get an array, and then you say, if this is greater than this, and then you, like, no, like, nobody wants to do any of that, okay? So, let's move to the next one, campaigns. Like, you won't get anything in route, so let's close it. Let's come here, like, close it, come here. See this? So, the only, see, it's like, bam, here. If it's a coroutine, call this. If it's not a coroutine, call this, okay? Like, one of the reasons why if statements and cyclomatic, but let's Google big word alert, cyclomatic complexity, the word that made me not get money, okay? Cyclomatic complexity. So let's come here and let's say cyclomatic complexity. Cyclomatic complexity. So, you see, it says it's a measurement developed by Thomas McCabe. Maybe I should put a Mac in my name to make it sound more English or make it sound more. So, it measures the number of linearly independent paths through a program module. Programs with lower cyclomatic complexity are easier to understand and less risky to modify, okay? And then, if you take a look down here, it says, it is a quantitative measure of the number of linearly independent paths through a program source code, okay? You see, if we even click, you see, we come here, if you go here, if you come here, if you like. So, for me to not teach if Macto. Yeah, I like that, Macto. Okay, so for me to not teach a lot of ifs, I think you need to give me an award actually, because I was able to get you to still solve problems without using as many ifs. Okay? But then again, it's not as if it's necessarily bad. I would much rather teach you the match statement, okay? Match in Python, okay? Than teach you the if, okay? And there you go. For your viewing pleasure, if you have a question, you can ask. Match parameter, case pattern 1, case pattern 2, case pattern 3, case is basically the switch statement in other programming languages that has been taken and Pythonized, okay? So I'd rather teach you this than teach you an if and give you programming tips that prevents you from writing a lot of ifs. Okay, so basically, in languages like Python, Java, okay, what happens is, let's come here. I can't remember the last time I wrote a Java program, so let's just go ahead and do it. Need a Java? Never. Okay? In Java, you have the switch, okay? And then you have case, and like that, and then you, like that. If you've used Java before, you understand what that's all about, okay? In Python, we have the match, which is basically the same thing, okay? So when we use the match, okay, what we're doing here is we're saying switch. And then the same way you do match, you put and then you say case, and then you do that, and then the same way, and then you say case 2. So it's basically the switch statement, but in Python, okay? So instead of you saying if this, then, if this, then, if this, then, you just match, and then it's a better primitive and better optimized by Python to give you what you want. Yes, Zainab, your hand is raised. I think many of the people that do the spamming and so they're asleep. So we should be able to. So it's recommended that you don't do the, like, it's better you use the match, okay? It's better you use the match as opposed to using if. As a matter of fact, let's see match versus if, Python, performance. The match statement is 86% faster than the if. The match statement is 86% faster than the if. I see your hand raised, Zainab. You have another question, I presume? This is so bitter. Do you understand the match statement now? Fine? Please, can you help me open this? Help me open it, please. Good. Let me show you. Let me show you something. Wait, let me tell 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 you something. Okay. So, interceptors, security. Okay. I want you to take a look at this code. Let me make it bigger. Hey, Zainab, are you awake? Are you sleeping? If you're there, let me know. How you doing? Okay. Take a look at this piece of code and tell me what you think. I wish the code was visible to the camera, but the people on the camera, I wish we could zoom in. But I think we're recording the screen, so it's still fine. So, if you take a look at that piece of code, you will notice that we have cookie is equals to request.cookies.get. Header is equals to request.headers.get. Okay? I could have come down here and I could have said something like, if not cookies, okay, and not header, okay, but instead, I said cookie, header, and I just went straight ahead and I behaved as if I don't even know that the cookie and the header could be empty, okay? I just went ahead and I did what I wanted to do. Like, I didn't bother with the whole, and then it was here where I said if they don't exist, then just go away, okay? I didn't even say then or and or whatever, okay? Then I come here and I keep what I want to keep, and then here I determine if it's a co-written function, so I can call this, or if it's not, so I can call this, okay? So it's possible for you to write if not cookies, then inside the if not cookies, you go and you write if not header, and then you go inside that one, and then you write return, and then you come outside, that means that there is else, and you have a nested, a deeply nested if and like, don't do it. When we talked about higher order functions, and I don't want to go back into this because I think the other conversations around the working of technology might actually be slightly better. But yeah, who am I to choose? If I insist he doesn't understand what he's looking at. The minute I'm going there, I'm already feeling sleepy. So let me step away, step away, step away. Are there any questions? Are there any questions? Is that a yes, there's a question, or no, there's no question? I think Ifan said he finally understood what he was when we were talking about the match case.
Bluetooth disconnected.
So I'm going to continue with the programming and the technical conversations and lessons, and I will just be not necessarily on code. So now there are a couple of things that
Bluetooth connected.
who is that person, please? Who is that person? Your Tina, you Abby? Please stop distracting. Okay, so when I was many years ago, there were a couple of products that we wanted to build or that I had in the pipeline. And one of the things that always stumped me was how a lot of people said that software development is hard, but for me, it never seemed that way. It's not that I'm saying that I'm intelligent. Like, learning languages can be very hard, okay? It was the whole, you don't know if you're going to get the software or not. Because the programmers are like gypsy people. So, I always had the notion that that is not true. Programmers would deliver if you gave them clear enough requirements, until I became a programmer and I realized that somewhere along the line, I drank the same Kool-Aid that those people drank. What do I mean? What is this lesson about? Question every single thing. Question every single thing, okay? That's how we get better as engineers. That's how we get better as engineers. Question everything. There is absolutely nothing that is sacrosanct. Everything can be questioned, okay? So I remember going and the first meeting I had with my engineers, one engineer wanted to do something one way, the other engineer wanted to do something another way. The beauty about computers is that a computer will allow you to do anything in any way you want. Okay? A computer will allow you to do anything in any way that you want. And if you believe you are right, the computer will tell you you're right. Okay? It is the outcome that is going to be this thing. Like earlier today, when we were taking a look at the program, we said that, let me sit down like this. We said that the worst kind of bug is the bug where you are looking for the bug, but like you think the program is working, but it's not working as it should until you go and you find out later that, oh yes, this value should not be. So imagine you created a program, and the program was supposed to calculate the another program that does it and shows you it's 300 liters. And then you check everybody's own and you discover it's 300 liters. It would be as if you should break somebody's head. And I said that is the worst kind of bug that you can have, okay? Now, how do you prevent these kinds of bugs from happening? Because we said that's the worst kind of bugs that you can have, but how do you prevent it from happening, okay? In computing, whenever you're writing code, you should be writing tests. Whenever you're writing code, you should be writing tests. If you don't have tests, like you are just like, unless you want to test it manually like we were doing when we were writing, and we were doing that because if you beat me, I'll not go and write tests with the kind of head my brain is carrying right now. I mean, the kind of brain my head is carrying right now. Like, if you beat me, I will not do it. Okay? I won't do it. But I will test with my hands and I'll test with my eyes until our brain is fresh again. Okay? However, if I were to go into a folder here, so let's come here. Whenever I touch this, I start sleeping. Okay, so if I type here PyTest, I hope you can see. You can see all these tests. Now, these are tests that I wrote. These are tests that I wrote, and tests are very, very nice. Writing tests is extremely important. So tired. Huh. Tests are very, very important, and you should be writing tests. You should always be writing tests, because any code that is not tested is wrong. Just take it like that. That is the easiest way to solve the issue of you should be writing tests at every given point in time. As a matter of fact, before you write code, you should write tests. If you're writing tests, then your code is assumed healthy. But it is possible that you're writing tests and your code is still going to be rubbish. Because sometimes you write tests and then you write tests so that you can write tests to pass. You write the test so that you can your code test will pass. Not because you want to test something. So away from writing tests, there are different ways via which, and the reason why I was talking about the engineers drinking from a Kool-Aid is because there are numerous things that can be done. There are numerous things that can be done to. There are numerous things that you can do as an engineer to make sure that your application is delivered on time. One of them is writing tests. So you have different kinds of tests. You have unit tests. You have integration tests. Okay. There's even behavior-driven development. Behavior-driven development. There are all manner of things nowadays. I won't be shocked if I see Christmas-driven development. Okay? But the whole idea is, if you have, so I'll give an example and then tell me what you think. I had a project to deliver. As an engineer, I had an engineering team of about 7, 8 people back then. And I had a project to deliver, a DHL project, extremely important. It was make or break. So I went to India. I traveled to India to go and meet my team. I stayed in India. And what we did was, we created a programming style that I call marathon-based programming. We created a programming style that I call marathon-based programming. What did I do in this marathon-based programming? What did I do? I told everybody, if you write one line of code, you die there. I'm joking, no. If you write one line of code, I am going to fight you like no man's business. If you write one line of code, I'm going to cut off your head. If you write one line of code, you and I are going to have issues. I don't want to see a single line of code written by anybody. They're like, so how are we going to deliver the project? I said, just write comments. I want you to go into the project and create every single class and every single function that you need and leave it empty and write comments. Write comments inside all of them. What the function will do, what it will return. Everybody, we must finish it today. So everybody just went in and they just writing comments. We wrote comments, wrote comments, wrote comments. We finished the entire project with comments. If you take the project and then you read it, it was just comments everywhere. Comments, 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 comments. When we were done, I said, okay, let's write tests. Let's start writing this thing. Now, imagine that everybody in a team has written comments. Somebody called Benjitis or Benjamin can come and take something that is written by somebody called Yotus. And because it is a comment, he is going to write the code exactly like, he doesn't need to go and start asking anybody. Like, everybody was just implementing everybody's work. Because this one says, I'm going to collect two numbers and I'm going to give you a Boolean. That one says, I know that thing gives me a Boolean. And we finished that thing sharper than anybody could say ABC. This was in 2016, thereabouts. And I said, this one is not sprint, this one is marathon. But it was a very successful style of programming. And I use it a lot. I don't implement, I just put the body of and I write the comment and I move on. That way you can finish an entire project just with comments alone. Okay? So you need to be doing testing. Okay? And another beautiful thing is if you write comments in that style, I'm not saying you should go and write comments, then it's easy for you to go and write tests, and then as you now start writing the functions so that the test will pass. Because if you have 5,000 things that are not yet done, and you have 5,000 tests that are all failing, you'll be motivated to make sure that your test reduces from 5,000 failing tests to 1,000 at least. So testing is good. You want to be testing, you want to be testing, you want to be testing. Okay? There's unit testing. There is unit testing. There is integration testing. Okay? They are all different in their applicability. They are all different in their applicability. Now imagine that we were building that thing for DHL. We had to test with what DHL had. We had to test our system with DHL's system. One of the challenges that we had was that DHL is notorious for using XML. XML is an EDI format, and DHL is notorious for using Java. So they're notorious for doing it. Well, they have very old systems and so. So they wanted us to take the HTML, read the HTML, and then after we read the HTML, we'll remove data from the HTML and we'll go and submit somewhere else in it. I was like, no, this is nonsense. That's also nonsense. What we're going to do is, we're going to take your HTML, and we're going to read it, and we're going to convert it into a dictionary. And we're going to keep it in that dictionary. Now, whenever you want that letter, let us know, and we'll give back to you. Okay? So what we did was we took the document they gave us, and then we created a map. We created a map. So if you give us a document, we don't care what documents you give us. We will create a map of that document, and we'll keep it in our system. And then when we bring our own is going to just look at the map and then fill it out, and you have a full-blown, and there's no need for XML. Okay? But you see, you had to integrate one system with another system. Any questions from the chat? So, programming as an activity is a social activity. Programming as an activity is a social activity. If you join a company, as a software engineer, within the first few months, you'll be in your honeymoon phase. It is in this honeymoon phase that you should find out everything you want to find out as an engineer. If you join a company, in the first 2 months, you're in your honeymoon phase. In this honeymoon phase, find out every single thing you want to find out about the company. So that after the 2 months, you sat down. You sat down very, very well. Like you don't sit down like you're very well entrenched. It's so that you'll succeed. It's not because you want to sit down. It's so that you what? So that you'll succeed. Okay? It's so that you'll succeed. In my experience, it will take you about 2 months to completely integrate with the company. For the people in the chat, did we understand the You know, when we take a look at computers today, we forget how ugly they were when they started out. Forgetting that they were just glorified vacuum machines. This is what the computers look like. Computers started out as a very dumb machine. They had pipes. And the first computer, when they say debug a computer, it's because there was actually a bug inside the computer. Because computers had, so they had tubes. They were massive systems. Somewhere along the line, it changed from somewhere along the line, the whole concept of computers changed drastically. It changed from light bulbs to electricity. Ones and zeros. Ones and zeros. First computers were like car machines. Babbage analytical engine.
You might what?
I want to sleep. I have 5 minutes of it. What time does it enter 10? Huh? It's fine now. You just keep talking about computers. Computer lesson, Abi. Talk about computers. There are many operating systems as long as we're talking about computers. Abi? There are many operating systems, and the operating system, when you switch on a computer, who knows what actually happens? Are we still going to write any code? Yes, we are. Adam says he comes on. It comes on. When you switch on the computer, it comes on. That's funny. But what actually happens when a computer, and what do we understand by this thing that we call computer? You know, I'm going to oversimplify as always. Okay? A computer understands ones and zeros, but what does it mean when we say it understands ones and zeros? When we say that a computer understands ones and zeros, what do we mean? You see, The reason why a computer is set to understand ones and zeros is because a computer is just a glorified calculator. It's just a glorified calculator. It's a calculator that has. It's a calculator that has a drug dealer. That's what the computer is. Let's explain. When you switch on the computer, yes, it comes on. But there's something called a BIOS. Abi? How many of you have heard of a BIOS before? When you switch on a computer, oversimplification, but when you switch on a computer, okay, electricity comes into the computer, and even when the computer is working, and you hear ones and zeros, think of electricity like a human being. Electricity comes into the computer opens the door, it goes in, that's one. And that electricity is coming, computer locks the door, it doesn't come in, that's 0. And that one comes, it opens the door, it comes in, that's 1. And that one wants to rush in, it closes the door, it doesn't come in, that's 0. So if you hear of logic gates, opening, closing, it is just 1, 0, 1. The engineers know what they are doing. They are the ones that did us this 419. Okay? It was the engineers that did us this trickery and told us they gave us a great computing device. Now, what is actually happening is there were 3.3 volt systems, 5.5 volt systems, and so on. Closer, higher up 1, lower down 0. So, on this screen that is here, you can take a look at my screen, okay? Let's show pixel. Now, so you see this things here, you see this dots. They are pixels, and every pixel on a screen from here to here, or from here on the screen, okay, all the way to here, is pixel 0 can be 11011111. Pixel 01 can be 111, 11101, like that. So the pixels are changing in color very rapidly, and you say, oh, James Bond is fighting. The computer does not know that James Bond is fighting, it just knows that it's changing the colors very rapidly, and then you interpret it as a video, okay? But what happens when you turn on the computer? Adam said it comes on. What happens is that electricity walks into the BIOS. And the BIOS says, if you go to room 305, you see a young man called Benji. His name is operating system. Go and catch him. So, he goes and he meets Benji. Okay? Benji says, yeah, let's see. Agbani, what do you have? He says, I have a monitor. Okay? What else do you have? I have a keyboard. Okay? What else do you have? I have a speaker. Okay? And then he finds all the things that the computer has. And then Benji is in room 303, Abi. Benji looks around. And Benji says, all my goons, follow me. Okay? I'm going out. So the computer is going to leave that room with ls, make directory, dir, all those commands. All of them will follow the computer out. Abi? Your operating system, it will go out and it will start screen. It will say, you, stay here and make sure this one is work. It will go on to do everything. Now, the computer basically has all these peripheral devices that is going to allow power go to, and it's just going to be changing ones and zeros on it. And you'll be saying, my computer, the display is sharp. But it's just ones and zeros, okay? That's all your computer will ever know, ones and zeros. So, as a result of this, and because of how dumb the computer is, it doesn't know how to play video. It doesn't know how to play audio. It doesn't know how to show a JPG. It doesn't know how to do anything, to be honest. It just knows how to start different things and send ones and zeros to them. So your computer is sitting down, picking its teeth, and then an application will come and say, Mr. Computer, my name is Adobe PDF. If you see any file with .pdf extension, call me. And then it will bounce. Computer will say, okay, let's go and stay in room 555. Tomorrow you bring PDF extension, computer sees it, say, gang, finally, room 555, come. And then, say she does not like Adobe PDF Reader, so she goes and she installs Foxit Reader. That she will prepare her husband and show him that she has Foxit and Adobe Reader. And then the computer says, say wait, how far now? Which of these things do you want me to use and open the PDF Reader? Okay? I have one in 555. I have one in 333. Which of them am I going to use to open the PDF Reader? She said, don't ask me, Joe. Let me go ask my husband. He's the computer scientist. So, but on a more serious note, if Auntie Sewe installs more PDF viewers on her computer and she wants to open a PDF file, she will see all of them. The computer will say, which of them do you want to use to open this file? It will not say, choose one as default. You've seen that thing before, Abi? So that next time I'm not going to ask you, stop stressing my life. I want to sit down inside here and be picking my teeth. You're telling me I should want to be telling, okay? So the computer itself doesn't know what to do with anything. It is just there. Its own is that when the computer starts, as electricity can enter, BIOS go tell and go and meet that guy. Now you be shaman. The computer will come open and say, I'm be shaman. I say, the hard disk, or you start to the row. Screen, or you start to the collect light. Or you come here, come collect water. It doesn't do anything, okay? The computer, this is a simplification. It doesn't know anything, okay? It doesn't know anything. However, it is a very fast idiot. For an idiot, it is extremely fast. For something so dumb, the computer is extremely powerful. Because, do you know what it means for something to be gigahertz? I want engineers now, now. It's a lot of things that are happening in 1 second, though. Many things are happening. Like in 1 second, you don't calculate, go ahead and come back. I know some people that are as fast as computer in calculating too. It don't calculate, go everywhere. So the computer is it's a very fast idiot. So if you tell it calculate a number, before you finish, it has calculated the number, it says this one, 5 billion times something, then my friend can go from here. It is able to calculate at high speeds, but it is still a dumb device. That is why when we were talking about asynchronicity and concurrency, we said that in less than 1/10 of a second, your computer has done for like 5 million things. Not be joke. In less than 1/10 of a second, it has done for like 5 million. Like it has, like you're still here thinking of it don't do 5 million things. But you see, those 5 million things are things that Benji had to sit down and write painstakingly and say, you this dumb block-headed machine. Interpret this file line by line. See, it is so dumb that if he goes and he sees that Benji made a semicolon where he's not supposed to put it, you say, so go back and go and sit down. Throw up his hand in the air. That is how dumb the computer is. It doesn't know, garbage in, garbage out. If Benji just makes more mistake, it will be celebrated. It means he sees it, just sit and just say, this one is, just go back and go and sit. I don't know what to do again. Okay? So a programmer must painstakingly tell the computer what to do. Even the hard disk that it is supposed to start, he must sit down and write it explicitly. You this blockhead. I know you run faster than the speed of light. Or you run faster than the speed of light and go and tell this one to stand up and give him this thing. Okay? So the computer by itself is very dumb. It's very, very dumb. So when you have a piece of file, and this is why we say it's everything in your computer is a file. Even your folders are files behind the scenes, okay? But if we think about it from a very, very well abstracted layer, your file is the ones and zeros in your computer. Your folder is the hard disk itself. Okay? From a very loose, if you want to understand it from a loose perspective, okay? The files are the ones and zeros. Your folder is the hard disk. You see when you open your computer, you see C drive. You see big C drive, just like that is just a folder. Abi? When you open the C drive, you see that maybe Ujamati created like 10 different things, and Caleb created like 50 different things, and Bill Gates created like 100 different. It just is the same. It's the same C drive. It is the exact same C drive. You just said create this room, create that room, create that room, create this room. Okay. The only thing that really exists on this blockhead is a file, because the only thing this guy knows is 1 and 0. And so the minute you tell it, play a movie, it will run at the speed of that 5 billion that he has. And go and take that file and run, I'm going to meet Benji in 555, take. And then Benji will start playing it. It will run, I'm going to sit there again. And be doing 5 million things in a second. So the computer itself is an extremely dumb device. So because of how powerful it is, people are always looking for things to give it. They're always looking for things to give it. Because before you say ABC, this computer will be here. You don't reach US, go collect movie, come back. You are still thinking of how you stand up and you go downstairs to your car. It have go to US long and collect film and come back and put it on the computer. Okay? So it is extremely powerful. It is, at least a modern one is powerful. It's extremely fast. Olden days computer, I think they were like 4 megabytes. How many? They're like, it was ridiculous how those things. I think the first computer self could even fit on the 250 something kilobytes. This thing. It was ridiculous. I have to Google it. It was terrible. I remember back then, we'll get floppy disks. We'll open the floppy disk and be looking at that film inside. We'll be playing with it. Like, it had some video games that we'll go and copy on floppy. Any floppy we see, we'll copy video game inside. Any floppy we see, video game was entered inside. So, we've come a long way from the floppy disk. And even things like the CD drive, okay, I'm going to oversimplify it. Because the computer understands only ones and zeros, when you put a CD in a computer, let's simplify it for you. What is happening is that the CD lens is shooting light up, and then if the light is reflected, it is a 1. If the light is not reflected, it is a 0. Are you following? This is, of course, a simplification. Abi? Because there's encodings and other things, but I'm just giving you an idea for you to understand that everything will ultimately come to that computer as a what? As 1 and 0. Okay? Again, it's a simplification, but that's what is going on. Because you, of course, in detail, you have registers and you have so many other things that are going that are helping. But if you want to write a movie or a Tom and Jerry thing about the computer, it is 1 and 0. A very big, fat-headed Tom sitting down, faster than anything, but cannot catch Jerry. Okay? That is what a computer is. Okay? So yes, Adam, it comes on, but because of how powerful it is, people have created programming languages that use the speed of a computer to do things. Okay? And that's why we say your job as a programmer is just playing with data, moving data from one form to another, because the only thing in the computer is data, by the way. That's the only thing in the computer. Okay? So, the question then we'll ask is your phone a computer? For all the people, Zainab, is your phone a computer? Zainab has gone to sleep. Is your phone a computer? Is your phone a computer? Is your phone a computer? Why is the phone a computer? Yep. So we're going to continue programming. Okay. We're going to continue programming. So think of this like the fundamentals of coming from the ground up. Okay. We are starting from the ground up. We're starting from the ground up. Okay. What is the job of a programmer? Abby, what is the relationship of a programmer to a product manager? Who is it that says what? Okay. So think of this coming from the ground up. So if we are talking about the computer being a very dumb device, and I asked, is your phone a computer? And you say yes, what differentiates your phone from a computer? What differentiates your phone from a computer? To what original says yes, it is. It's a computer. So what differentiates the phone from a computer? Why is your phone a computer? You know the earliest definitions of a computer was that a computer is a device like that. Our primary school definition of computer, about how it collects data, processes data, saves data, yabba yabba yabba, and then so something is on the computer. But in today's landscape, where almost everything can do that, even your microwave can do it. Doesn't mean your microwave is a computer, because then technically it is. Okay. I think in today's context, particularly for the purpose of this lesson and for the purpose of programming, okay, a computer is anything that allows you to program. Okay? Anything that allows you to program. So in other words, if it allows you to program, then it's a computer. Okay? Then it's a computer. I'm going to take a quick break. Hello. Just come.
said he wants to call it. Let's call it.
Hello everyone, can you hear me? I want to thank everybody for helping us to get to this point. This is where I bow out. I want to thank everybody for helping us get to this point. We have been able to go above with your help. You have been an amazing sport and you are part of history. Thank you very much.